Hi, my name is Derek Smith, and I'll be showing you how to do the difference between the shortest distance between 2 points. The mathematical goal is to support students' visuals, understanding of different measurements and angles, maintaining 3 different values, and understanding the difference between 2 points, all being obstructed by another condition. The pedagogical goals shows how hard to correctly eyeball several distances and determine which ones are the correct length to satisfy the answer. Too many values can confuse and frustrate students during class. I would ask, what ways can I determine values as I adjust to lengths? If the starting point and end point change, how will I be able to adjust and find the new length? And the final technology goal was to create an image of a river with 2 points, one above and one below the image, while a perpendicular bridge goes along the middle. Students can scroll along the point at the top of the river as it changes the distances to determine the shortest outcome, and they can also use it to determine the farthest distance. And here's my picture. It's the goal is to drag point C along line M to determine the values of P and Q. This is M, this is P, N, Q. The problem is, given a river with 2 parallel banks, M and L, the 2 houses, S and R, where should the bridge N, being perpendicular to the banks, be placed in order to minimize the distance between S and R? Add the 3 line segments P and Q to determine the shortest value. And as you can tell, this C goes up and down. And as it goes up and down, the lengths change, P, N, and Q. Here's my parallelogram dimensions. This helps determine the same lengths to prove that it's parallelogram, and SR is the distance from here to here. It'll be even shorter, but we want the shortest lengths over the river. So the best way you'd think to accomplish this was have the shortest distance for P, or have the shortest distance to R, but in terms it'll create longer distances oppositely of each other. So the best way to find the correct distance would be to show the hint, which would match the angles until they are equivalent to each other. The first angle SCD and the second RDC, which is shown here, here, and here. So when you move along to the C, if you can get them equivalent to each other, or about, and if you need help, you can use the arrow keys to slowly go across, they'll reach the same angle, and giving you the solution 5.36 inches. And if you, after already adding these 3 up, if you scroll, you'll notice this value getting bigger, and then if you go back to the center, it'll get smaller until it reaches that point and then gets bigger again. And both ways in between. And if you were going to change both these points and messing it up entirely, getting a different bridge across, if you match up these two angles again as such, it should determine the shortest distance here. Because if you go anywhere else, other directions, it'll just go up. I feel that this helps show how you can free range a point into different lengths, and how the angles can help determine different values. Thank you.